Thanks for joining us again. You know, we've had a lot of industry experts come visit the project here, to talk about different facets, whether it be insulation or roofing or other things that go on, but I never really reached out to somebody that takes care more in the commercial domain. So today I invited one of our TACO employees, Rich Medairos, to come down and give us some insight for that he would think about on a commercial project. So let's meet him. Hey, Rich.
Hey, Dave, how you doing?
Appreciate it. You find it okay?
I did. It was a little weird running through the woods and stuff, but I found the building
yeah,
coming out of the ground.
Awesome. So this is the project.
It looks great. It's terrific looking.
Yeah, especially from the backside, right?
It is. Yeah.
Well, why don't we take a look inside, Rich, and can see what it's all about. But before that, just curious, what is your actual job and title over at TACO?
Well, I'm a senior systems engineer for the commercial group, and I get involved with working with engineers all over the country in designing commercial HVAC systems.
Oh, okay.
And one of the things I really like about the residential is that you're taking a lot of the components that are in a commercial system and you're shrinking them down to fit into a nice little package for a residential project.
Yeah. We even do in the company. We have a residential versus commercial. We're trying to lose that small system components, large system components kind of idea there.
So with a house this tight between the insulation and the windows and all of those things, how are you dealing with indoor air quality?
That's a really good question. And that's I'm glad you're here and we brought that up. But that is a concern of mine. I've done a super insulated home, a few of them before, and how we address that was HRV, air-to-air exchanger, but the heat recovery style. Okay. Yeah, I guess in the South they do a little more of the energy recovery, but up here I picked an HRV. And what that is, we're going to pull from the kitchen and the bathrooms. We think those are the odor-producing areas and exhaust that out, but take the heat out of it and then replace that air back in the common, like the return ductwork of the HVAC system.
So your unit that does that exchange of heat with the air moving out and the air moving in, where's that located?
Actually, we have it up in the attic. That's where all our mechanicals are, up in the attic. My little thing is, I don't like grills or ductwork in the floor, so I like to feed from above. Okay. So with the nature of the construction, it all made sense. It is conditioned space. Anything under our roof rafters is conditioned space. So I say it's the attic, but really it's just an extension of a mechanical room, per se. So the ductwork and everything else up there. Well, Rich, this is the unit I was talking about. This is a generically air-to-air exchanger, but actually it is called HRV, Heat Recovery Ventilator.
Okay.
And the idea, again, there's two connections on this side and then two connections on the other side, which I haven't really made yet. On this side was really their indoor air. So we would pull stale air from the bathrooms and kitchen like we talked before. That would go into one side.
And that would be exhausted?
Yep, be exhausted, but I try to take the heat out of that with the incoming air. So on the other end there are two. I would have a fresh air intake and a stale air exhaust, and that's why this manufacturer uses blue as a reference on those, and we'll put them through that end wall over there. When we get the siding up to a certain level so we can plan that box nice, then we'll cut through and make that connection over there.
And typically, how far away do you have to keep the...
Well, that's a good thing. You really don't want it to short cycle, so you don't want to have a concentric or one right next to it because the air will just go like that. A minimum of 6 feet, but you also got to watch, do we have a flue? Do we have any other things that may put pollutants out? I don't want to suck that back in. Kind of the joke is, one of the houses we built, we put one of these units in and woke up in the middle of the night. What the heck is that smell? A skunk had sprayed outside, but the unit did just what it's supposed to do, constantly bringing in that outdoor air in. So we had a little skunk. Quick,
so it became a skunkulator.
Yeah, a skunkulator. So anyhow, but the idea is with a very tight house, I really worry about we're getting fresh air or just, building materials. Some things have formaldehydes in it. You try to minimize, you try to do all that, but there could be off-gassing of other things. And a product like this will make sure that we always have that fresh air entering, but we're not wasting, the heat, not leaving a window open or other things. We can, pull the heat of that stale air we're getting rid of, put it back into the system.
So this is really a very nice compact unit. Can we open it up and take a look?
Yeah, sure. There's 3 clips right along the top if you want to get one of those. Yeah, 2. There we go.
This one there.
And this particular one is a dual core. Let me just let it swing down.
Okay.
So here, this would be that indoor stale air coming in this way,
Going in that direction.
right here. So we have a filter if there was any obstruction. Comes down, goes out this way, goes back through here, this one, and then back, and that's the output. Fresh air would come in from this bottom vent over here, go through the bottom of this core where the filter is, come through, go back down here, come through, go back down on this side, and then be replaced in the building.
And this section over here houses the fans
Right.
for the exhaust and the fresh air.
Right, exactly.
That's really a nice compact unit.
There's many different ways that we could put that fresh air back in the building. You could do it in a stairwell, a common area. We typically don't put it in each room, but we put it in like a common area. Or if you actually have a mechanical system, ductwork,
Yep.
sometimes we just put it in the return of that, and that kind of diffuses through. Even if that system's off, that fresh air enters the building and it will make its way going through there. So that's how I did it in this case.
So Dave, now that we've got the heat recovery unit taking as much heat from the air as possible, then we send that air over to the air handling units themselves. And it looks like you've got 2 of them up here.
Yeah, we do, Rich. I have 2 different zones. Have one up, one down, and that's kind of the thought process. So the recovery, the requirement of this building is so low that I decided to zone that way. So just have one zone up, because our lifestyle for us, these bedrooms or this whole area will be rarely used. So why be conditioning it the same way that we're doing downstairs?
Sure.
So we picked a much smaller unit. This is probably only like a little over a ton output. For those people who don't know what a ton, 12,000 BTUs is roughly a ton, but
So 12,000 BTUs is actually, it's about the size of a good-sized window unit
Yep.
in terms of doing the entire upstairs of the house.
Right.
So what makes this unit a little bit different than most is this actually uses hot water for heating in the wintertime, correct?
yes.
And then in the summertime, you're going to use chilled water.
Well, that's right up your alley. It's like a commercial job. Yeah, so Rich, this one was the unit for downstairs. And since we are going to spend most of our time on that first floor, I put more of a high efficiency filter on this. I put a really 3-inch pleated Marv 13, I think, again, to really filter the air and to help out with that on that system. We put that on the main unit, where the other one might just have more of a standard filtration. Now, Richie, we were just saying when we were upstairs, about the ventilation on demand. I almost have that same thought process here. I have a range hood, that would be on top. I have a dryer. So I have to interlock or do something, the same thing. When I turn this on and I create a negative pressure, I got to make sure I compensate that by something turning on to make up for that pressure being lost.
So are you going to set up a control strategy so that when the unit is actually turned on downstairs, it'll activate the ventilation unit up in the attic?
Well, right now the HRV is tied into those areas, and there's a boost that we can hit a button and it goes on high speed. That's
okay.
all great. That'll evacuate things. But if I'm having negative pressure situation, that's another thing that we have to address. I'll have to look at that. Am I going to have a louver open somewhere to kind of compensate that
Sure.
negative pressure, because I got a dryer with lint and high humidity? I want to get rid of that. And again, range hood, if you turn that on, all of a sudden we'll get into a negative pressure situation. Whether it's automated or mechanical, we're going to try to figure out. Dryer, I could probably easy automate.
Sure.
That would be much easier. Current sensor or something like that, and pick up that use and turn on. But
So the way we do it in a commercial building is we actually measure the pressure inside the building relative to the outside. So if the pressure gets lower than the outside, then that means that the air is trying to come in. If the pressure is greater in the inside, that means it's trying to push out. So we can vary the speeds of our ventilation fans in order to compensate to make the pressure as neutral as possible.
Wow.
So that's the way we do it in commercial
Well,
buildings.
I should see if that manufacturer has a suggestion of that HRV. Is there a way to address that? Maybe dampering the air going out so we get a little more positive pressure, or something like that.
Right.
See how they address it, or
Right.
change the fan speed.
That's a very common method, actually, is to modulate a damper as a function of the pressure inside the building. So that could be a solution for you.
Okay. All right. Well, good. Another neat thing I wanted to show you, Rich, was we're going to do residential sprinkler system in here, and it's a little different than you think of commercial. Where rigid pipe and all this other stuff. Ours is actually part of the cold water line, the potable system. So actually, if I turn on a fixture up here, I may be pulling through the basement, the middle, and here all
All at the same
together
time.
to minimize that stagnation.
So one thing you might want to think about a little bit is this piping up here that has the sprinkler, that's going to circulate domestic cold water through it. And domestic cold water, especially in the summertime, can be below the dew point temperature. So how do you keep the piping from
Well,
dripping?
the thing is, it's not all coming through one section. Since it is so spread out, the flow will be so small through each one of these areas that it's not like a ton of water going through a big main where every time you turn on a faucet, there's only, say, maybe there's only an eighth of the flow of a small fixture is going through this one loop. An eighth is going through there, each the level. So it all kind of works together to get to that end result. So that's something for me to understand. We want to keep a check on that indoor humidity too. That will help with it too. Everything is in the conditioned envelope, so it should be fairly well for that. So again, even though we look at it where it's not in the attic, it's still in conditioned space because the nature of our system that we did here.
Plus the piping has some inherent insulation as part of that system. That's fascinating.
Yeah,
and then this is the head.
Yeah, so basically what it is this is how it will be mounted. And then after it's sheetrock, they take out the plug that protects it. And then we have a cap on here. And this will be just twisted in until it goes flush with the sheetrock. So the only thing you really see is just that flush cap on there. A little beat up on this case because it's my little demo. But the idea with this is this has little weldments in here, and when it gets to a certain temperature, that drops out, as well as, of course, the element in a standard sprinkler head. It would drop down with the pressure of the water and disperse that pattern out there.
So Dave, it looks like you've incorporated a lot of the systems that you would typically find in a commercial building into your residential project. And by the way, if you need more information about any of this stuff, you can go to TACO's website, and there's all kinds of information there on residential systems and commercial systems. You might even come up with some new ideas on how you might even incorporate some other commercial systems by downsizing them, putting them in a residential project. Thanks for having me out.
Thank you for coming down, Rich.
Thanks, Dave. I really appreciate it.
We'll reach
Good to
out
see you
as we
again.
get a little closer.
Sounds great. Love to come back.
All right.
Take care.
Yeah, that was great. Rich came all the way down from Rhode Island there. Actually, he lives in Massachusetts, but anyhow, came down, visited the job site, gave us his insight. The guy is so knowledgeable. It's amazing of all the different projects he's been on there and resources. So stay tuned. We really have some great material coming your way.